All right. Through section 1, 2, 3, and 4 question.
For the last one, you didn't finish how to answer it.
Yeah.
For number 12. Yeah, you didn't finish part C.
Part C. I know. Come on. I thought you were gonna figure it out, but all right. So can you give me your question? Can you give me your set? So that was question. What was question? Number?
Log 5 of 3.
Log 5 of 3. And what was question number?
It was 12.
So this is 12 on section 4.4, right?
Yeah.
All right. In part A, part 1, we found limits for this guy, upper and lower limits. And for this, we discovered that 3 was between 5 to the first and 5 raised to power 0. Why did we pick 5 to the 0 and 5 to the 1? We want it to be the same as this base. So 5 to the 0 is 1, 5 to the 1 is 5, 3 was between these two. So, and then I took logarithm of all three sides, log, and picking this base 5 is now going to pay off because these will cancel out. We just, in part 1, discovered that log 5 of 3 is between 0 and 1. So this was part 1. In part 2, we don't have calculators, basic calculators that can compute base 5. We switch base 5 to either 10 or ln. I don't know which one you prefer. I think we did log base 10. Let's do ln today. We change it to ln. You put a new bases top and bottom, and you put the top number to the top and bottom number to the bottom, and compute ln3 and ln5. And what is ln3? You need to take a calculator and get the digits for this. I think it's 1 point something. All right, and compute ln5. Again, 1 point something, and divide each other up to 4 decimals. So this is a calculator use question. You change the base to ln, put 3 to the top, 5 to the bottom, punch in the numbers into calculator, divide. And in part C, this is the part we haven't done, they say, and please can you do this and tell me the answer? Up to
0.6826.
0.6826. So in part B, we found this one is 0.826. Since we rounded this off, it's not exact, so we don't use equal sign, we use approximately sign. This means approximately. They say convert this into exponential. And we know how to do this. How do you change a logarithm into exponential back to exponential? You first write the base of the exponential, which is 5. Put the answer to the top. And the right side becomes this number. Again, this is approximation because it's not exact. The reason why they want us to convert, they don't say why, just convert and you're done with it, but why do you think they want us to convert it into exponential? To verify we did this approximation right or not. How do I know this is the right answer for logarithm? I change it to exponential and compute this exponential in the calculator and see if it's really 3. So let's compute that. 5 to the, what is that? 0.6826. Is it really 3? There you go. It's almost 3. Right? So you computed this logarithm almost correct, except it's roughly, there is a little error because of the approximation. Okay? All right. We are starting 4.5 unless you have any questions in the previous section. 4.4 is over. In 4.4 we have completed all our laws about logarithms. We are master of logarithms, and before that in 4.1 and 2 we found inverse functions and exponential functions. 4.5 is where we apply everything we learned. We applied what we learned about exponential and logarithmic equations into their equations, equation solving methods. We make use of all what we learned in previous sections to solve equations, such as question 1. Okay? Now, what kind of expressions do you see here? There are 2 different topics together in this section. One is logarithmic equations, the other one is exponential. Do you see any kind of logarithms here? No. We first investigate exponential expressions, but just because we have exponentials here doesn't mean we will never use logarithms. Yeah, sometimes later on we will use them if we are stuck. If we don't have any other cure, any other method, we will use logarithms. But for some simple questions, you don't need that tough and strong logarithm tools. We just can figure out the solution by simple reasoning. And it's this. If you have 2 expressions with the same base b, you see the numbers matching b, and this is what you can do. You can cross out b's and look what's left. X has to be equal y. In other words, if 2 exponentials match, then the tops must match. All right, how can I make use of that fact here? You need to have 1 exponential on the left, 1 exponential on the right. I have 1 exponential on the left, and this is no exponential. Right. This is no exponential. We need to make this in an exponent form. And as you said, 5 cubed is 125. So there you go. You have an exponent form on the right and on the left. So I'm going to go ahead and say, we'll just continue here. 5 2t plus 5 is equal to actually 5 cubed. Look what's going on. Exact same situation here. B is 5, 5 match. If there is a matching pair of bases, you can just ignore them and set the tops equal. Set the tops 2t plus 5 equals 3, and just solve for it. I subtract 5 from both sides and get -2, right? Just send the 5 to the other side. And t is 1. Okay? We solved that, we're done. Well, if you are curious, this is the right solution, whether you made a mistake or not, take this one, plug it in here, and see if you get 125. Do we really get it? 2, no.
-1.
We don't get it. I found a mistake. Look, 2 times 1 is 2, add 5, 7. 5 to the 7 is, there is no way it's 125. And cut the mistake, it's -1. -2 plus 5 is 3 now. 5 cubed is 125. Now I'm feeling good. Alright? So this thing is -1. Easy, correct? Once you're lucky to bring both sides to the same base, I said lucky, then you're good. Well, there will be unfortunate times. This is still, number 2 is still, you're lucky if you can bring both sides to same base. How come? Doesn't look like the same base, right? This is base 7, this is 1/7. They are not relevant. Can you match them? Can you play a trick, math trick, and make one of them exactly the same as the other? Do you know the trick? Put 1/7. Flip 1/7. I can flip it. It's 7/1. Can I just flip like that? Somebody needs to pay a price, right? So Austin says, I like that idea. We need to flip 1/7 as 7/1. Okay. You can't just flip in the middle of the equation like that. Somebody needs to pay a price. Yeah. If you flip the base into opposite 7/1, this power gets a negative sign. So we introduce the negative to what? Only t, so it's minus t? No, the both. Both gets the minus, so this turns into minus plus 7. We've been doing that for a while, remember? Like this one. We've been doing it with negative exponents. I said whenever you see a negative power, flip this base, and you used to make it, this is actually 2/1. You used to flip it to 2/1 into 1/2, and this guy pays the price and turns into plus 3, and you would move this plus 3 here and make it 1/2 cubed. I really didn't show all this detail. I just told you that 2 to the minus 3 is 1/2 cubed always. There's actually a flipping going on there, okay? So we have now 3t plus 3 is 7. 7/1 is 7. Minus t plus 7. Alright, let's take our cancellation color, get them out, and match the terms. 3t plus 3 minus t plus 7. Alright, I will move minus t to the left, 3 to the right. Can I do this quickly now? Now you guys almost over with this course. You're a master of these skills, right? So 4t equals minus 4. But just let me know if I make a mistake or you don't catch one step. Let me know. Like I did a mistake. Yeah, thanks. Plus 4 is the right one. And I divide both sides by 4, and I get 1. I keep getting 1. Is this correct this time? I believe so. Okay. Any questions? This wasn't too bad as well. Let's take a look at the next one. We're stuck now. Because I see a new method, that means our old strategy is not going to work. Is it not going to work? Maybe. I don't know. Let's see. What we do is we try to turn both sides into powers. Can you guys make 68 into power of something? What power of 3 is 68? Is it 1? No. 2? No, 2 is 9. 3 cubed is 27. 4? 81. Oops, I skipped 68. So we're not making it. We're not making it. And what can we do? Read the steps. It says find exponential expressions and isolate them on one side of the equation. Because sometimes you may have more than one. You need to keep one on the left, one on the right if you have two. And sometimes there are loose numbers like 3x minus 5. You need to combine numbers together. But isolation is our first step, and it's not required for this case because this guy, do you see anything else besides 3x? Do you see anything else on this side? No. So this has already been isolated. So step 1 is void. We don't have to. Yeah. Step 2 says our old method didn't work, right? Our old method strategy didn't work. Now we need to go use strong weapons. One level up. This is a master question. It looks like a simple question, but ugly question. We need to level up our weapons and use a logarithm weapon this time. They say take logarithm of both sides. That's your second weapon again. You are allowed to take logarithms of both sides of the equation. Okay, I'll take it then. I'll take put log to the left and log to the right. But the question is, logarithms need a base. Which base we are going to go with? I can pick anything. 2, 5, as long as I put it in the same side. 5, 5, 10, 10, E. Which one makes best sense? What's the best choice? Yeah. What did you say? Base 10 is a good one. Because why we like base 10? Because your calculator has a button for it. You can compute any logarithm base 10. ln makes sense. You can take ln. Or if you don't like either one, if you want to go with any other number than 10 or e, what would be for this question? What would it be?
0.
No, we can't go with 0. 0 is not allowed in bases. 3. Why you guys insist on 3? By the way, why do I have 3x here? I told you, warn me before it's too late. This is not 3x, right? It's 68. Okay? Some people prefer 3. Why? Why? Tell me why. Yeah, because these two cancel if you choose 3. Okay? If you choose 3, they will cancel, and you will have this. Okay. Mathematically, when I ask you solve this equation, this is your final exact answer. But not in this question, because they don't want just a solution. Yeah, this is the exact value of the solution. They also want in part 2 an approximate solution up to 4 decimal places. So the question is over, but they still want to see some decimal value of this thing. Well, we have a problem. I don't know how to compute this with a calculator, because my calculator doesn't have base 3 option. Yours have, I know, but not mine. So what can I do?
68 divided by log of 3.
Right, we go with change of base. Alright, if you choose log 3, you need to go with change of base to approximate it. So our calculators have log base 10 or ln. You have 2 options. You can do log 10 or ln and put 68 to the top. This is the change of base formula. And this, all we need to do is compute these 2 and divide one into another. Log, what was that? 68 divide by log 3, right? Alright, it's not that smart, so let's get smarter maybe by putting parentheses. maybe separate this up. Yeah, there you go. 3.8407. I don't know how many decimals it wants. 4 decimals. So I'm gonna round up this one to 76 to 8. So remind me, the last one should be 8. Oh, this is log base 368, right? Check. And this one is 8. Good. Alright. Someone earlier said, what if we choose log base 10 or e? That's possible as well. I wanted to show you how that one works out quickly. So, same question. This time, I'm going to use log base 10, or just log. That means base 10. Alright? This time, can I do that? Can I do that? Can I cancel them? No, you can't. You cannot, because this is base 10, this is base 3. I can't. So, how can I get x by itself then? X is on the up on the tower locked in. How can I bring this to the floor? How? Yeah, there is just a rule for that. Logarithms takes any power on top of the base and into front. That's why we are taking the log of both sides. That's why we are using this tool, so to bring x to floor. So it's log 3, log 68. Guess what I'm going to do next? I will divide both sides by log 3. Cancel. Do you see any difference in the solutions? Aren't they the same? Look, they are the same. Alright? No matter which way you prefer, you will end up with the same estimate. But this is more compact for entering purposes. Instead of putting two things, separating with a division, this is better looking. So if you have a choice, go with the same base. Otherwise, use log or 10. I'm sorry, ln. Alright? Any questions? Alright, this was quite simple. This is a little bit one level up. First off, circle your exponential. Where is the exponential? Where is the base and a power? This. Check if that red circle is the only thing you observe on the left side. Is it the only thing? Is it? No. So we need to bring this 4100 to the right side. Simply add both sides that. Okay, very good. Now, step 1, over. Next, take logarithms. Which kind? Which kind are you going to take? Yeah, because it's base 10 already. So base 10 or regular log, common log, that's what we call, is the best. Of course these will cancel and get 4 plus 7t equals log this stuff. And get t all by itself. How? Subtract 4. Alright. subtract from here and divide by 7. There you go, you have it. I tried to hand calculate this if I have any hope to bring 101,100 into power of 10, because this is base 10. If I can bring into power of 10, maybe they cancel, but I don't think it's gonna work. Actually, a little bit it may work, because this is 100 times 10, 11. But I think this is acceptable answer. I don't want to compute better than this. We can't get exactly this logarithm resolved, but we can kind of simplify it. That's what I mean here. Isn't that 10, 11 times 100? Just I separated the last two zeros as 100. And I'm just looking at this part. And I can separate this into two parts. Log 10, 11 plus log 100 is 10 squared. Log and 10 cancels because they are the same base. And this thing is only 2. Log 10, 11 plus 2 is what this thing simplifies to. And this minus 4 and plus 2 cancels to minus 2. That's how much I can simplify this thing. But I think it will lack the initial answer as well. I will use the earlier answer. Yeah, it lacked the earlier one. And you just need to put this into a calculator and get it rounded into 4 decimal places, which I will leave it to you. Okay. Alright, it's getting messier. This time, for the first time, you have 2 different exponentials. 2 different. One on the left. Look, this is an exponential form. This is an exponential form. You have 2 of them. So you need to get them isolated on each side. Yeah, they are already isolated. I don't see anything else next to them. So we are ready to stage 2. We're going to take logarithm. But which logarithm are you going to choose? Which one makes best sense? Since there is no match in the bases, I recommend go with base 10 or ln. Can I do logarithm base 7? Yeah, you can, but later you may need to, for calculations, you may need to also change to 10 or ln. Can I go with base 11? Yes, you can. But if you want to go to the direct answer, best shortcut is go with common logarithm, base 10 or ln. Okay? So which one you like? We haven't used ln for a while. Why don't we go with ln? Choose ln on both sides. And logarithm will do its magic. What is the magic? logarithm brings all the powers, the entire power around the base to in front. Best thing as well. So 1 plus 7x in the front side, ln 7, 4x minus 3 times ln 11. Now you need to bring, x's are on the ground now, safe and secure. You need to bring them together, combine them, and isolate x on the left side. Get x by itself. And that will be challenging for some of you guys. What would you do? How do you get x's together? First off, you need to clear all parentheses. All parentheses must be clear. So I see multiplication here. I will multiply, I will just leave one like that, 7x and ln 7. Actually, I like x in front. Can I do 7 ln 7x? 7 ln 7 is the number. I'm sorry, coefficients always numbers first, then x. So this is 7 ln 7x. Am I right? Am I doing it right? Yeah, we need to multiply both with ln 7. So 1 times ln 7 is ln 7. Don't miss that part. And then 7 ln 7 many x minus ln 11 times 4x, that's 4 ln 11x, and minus 3 ln 11. Okay? Agree? Now where are my x's? Here and there. They must come to same side. Either you bring this to the left, this to the right. I like left. So I will move this next to here by flipping the sign of it, or subtract both sides the same quantity, this quantity. And I will bring this guy here to the number side by subtracting ln 7 from both sides. So 4 ln 11x comes to left minus 4 ln 11x. We have 7 already there. No, that's not 11, that's 7, right? Equals, this goes right, minus 3 ln 11 minus ln 7. What am I missing? Yeah, this x. Now you have minus 4x and 7x, so we need to combine this or factor x's. X's factor, and we group these two coefficients. Minus 7 ln 11 plus 7 ln 7 equals minus 3 ln 11 minus ln 7. Now how do I get x by itself? Can I add, simplify these things? No. They won't join each other. We do this. Divide both sides with this entire thing. You found it. Now, can you follow? Okay, let me review, summarize again. We took ln of both sides. Right? We brought powers in front, distributed, multiplied out with ln 7, 7 ln 7, ln 11, 4 ln 11x, 3 ln 11. We brought numbers together, x's on the left. Factored x's and divide both sides by the numbers, by the number in front. And this is the result, trust me. Okay? Now, can I do better than this? Can I combine these ln's? Yes, you can. If you have two ln's subtracted or added, we have a rule to combine them, right? If you have ln of u plus ln of v, if they are added together, how do you add them? How do you combine them? What's the rule? Multiplication. That's ln uv. If you have a minus, I wrote them yesterday with logarithms, but it works with ln as well. Ln u minus ln v is ln u over v. They're still here. No, they're not there. It's in the old file. Okay? But I wrote them yesterday with logarithms. Anyhow, if you want to combine these, you can, but I don't think it's necessary. So I believe this will be accepted. Because when you combine them, 11 cubed is not going to cancel with 7. I hope our answer will be accepted like this. First, let's match the question. Is it the same? Yep. All right, I need somebody to read this.
Negative 3 ln 11 minus ln 7 over negative 4 ln 11 plus 7 ln 7.
Good. Like that. We didn't have to combine them. But again, if you want to combine, you need to bring the number in front to the power and then take minus out and use addition product rule. And for the second one, you need to reorder. Take the plus one in front, minus one next, put the numbers in. So it's a lot of work. So I'm glad we didn't have to, because it's not really simplifying, it's just combining two ln's. And for approximate solution, I'm afraid you have to punch in all these to your calculator and get an approximate solution. Okay? Which I will leave to you. You're good with calculators, I'm not. Alright. Here's an interesting question. Tricky one though. I didn't put the solution technique we applied earlier because it's not gonna work. Why? No, not because of E. E is fine, I'm okay with E. Because this solution technique done here either needs only one exponential, like 1 and the other side is numbered, or if you have two of them, you shouldn't have any numbers around them. So you can directly take logarithm. Next one has two exponentials, one on the left, actually two on the left. Even I separate this one to this side, I can't get rid of this number. So unless these two all by itself on each side, you can't take ln or any logarithm. That 56 is gonna mess up things. So we are gonna use here a different idea, and I'm gonna give you a hint. Okay? Now, do you see this 2r? Can I write that as e to the r exponent 2? Like, isn't x to the 4 or x to the 6, let's say 6, the same as x cubed squared? Isn't x cubed times x cubed x to the 6? So when you multiply these, you get 6, right? Correct? So you can separate this 2 from r by pulling it outside, a little bit push it out. Okay? Keep r in. Next, I'm not going to touch that. E to r's are same. You see, they are actually same thing showed up twice, except this one has an extra 2. Now, for several minutes, just imagine, instead of these e to the r's, imagine them they are x's. Cover them with x's. Here is an x. Here is an x. If this question would be with x's, instead of e to the r's, cover e to the r's, imagine x's, what would your equation be? It would be x squared minus 10x minus 56. Not 86, but 56. This one is failing as well. Okay. Now, this is a kindergarten question now. No, not really. It's quadratic equation solving question. 1075. How do you solve quadratic equations? Factor, set each part into 0. Alright, and next question. What are each factors? X, I know x squared breaks as x. How do you break 56 into two pieces? When you add those two pieces, it's going to make minus 10. What two numbers multiply to 56, add to minus 10? Negative 14 and 4. I was thinking 7 and 8. No, it's not going to make 10. I thought 28 and 2. That's too far. And then 14 and 4 possibly can make minus 10 if I choose this 10 minus, this plus. This way, minus 14 times 4 is 56, minus 56. When I add them, it makes minus 10. That's how you factored it in 1075, right? Alright, let's set each into 0 and solve now. This is minus 4, right? And actually this is 14. You're done. you have solved this equation, the red equation. Our equation is not that one. You solved, you found x's. They want r's. So how can I reach back to r? Go back to r. This is x's.
Put ER in
Yeah. Remember what we called x to be. X is actually covering up. Uncover x now. Put back what it is. X was e to the r. So put those e to the r's back. This guy is e to the r. That guy is e to the r. And solve for those r's now. Okay. How do you solve an exponential equation? Set it into a number. Back to this question. Exponential, set it into number. How did we solve it? Like ER number. You just took logarithm, right? So I will take log of both sides. Take log. What log? Which one? Which one makes best sense? Is log base 10? No, ln is the best because ln has base e. I'm going to take ln of both sides. And these will cancel. You have r equals ln 14. These two cancel. You have r equals ln negative 4. And there is something wrong here. Now everything we did is purely correct. But there is something wrong with the answers, and let's see who's gonna spot what's wrong with these answers. Yes, we cannot compute logarithms of negative numbers. Actually, when you go back here, I said e to the r into a negative number, but exponential, e to the x, they are taking up, they are rising graphs, and they have range at positive values, 0 or more. How come you can expect e to the x or e to the r to be negative? So you could actually stop right here and say no solution, this can't be solution. Second reason again, we do not know ln of a negative number. There is no such thing. There is only one answer here, which is ln 14. And you can punch in and compute that if it's necessary. But they want first that number. Then they want the approximation. We can get it quickly. Always use some space. 263.90 to 40 places. All right. We have a little bit left. Actually, halfway through yet. We haven't started logarithmic equations yet, which will be on Friday.